So we're still having a few of the on-site attending people taking their places, but this gives me the opportunity to open this part of the FIRE Forum where you will see different sessions focusing on the different themes that we have heard about in the opening part. So we saw the evangelists set the stage, discuss a little bit the now and tomorrow of Earth observation. And with this panel, we'll start zooming in on some of the key subjects that we would like to analyze. I should say that whilst we are discussing, there is a very talented illustrator, Paolo, who is trying to capture all the ideas that are being exchanged here. So you will be seeing that on your screens as well. And of course, there will be, as was before, but now in a little bit more interactive way, we will use Slido. So we will be raising some questions that both the people here in the audience, but also anyone connecting remotely, will be able to either raise questions or actually answer and give their thoughts on some of the questions we will be raising. So I should say my name is Lefteris Mamais. I'm co-founder and director at Evenflow. We're one of the partners in FIRE. And we're also leading the development together, of course, with our partners of the roadmap for the development of the EO sector. So this forum is really a key component for that. And all the discussions that you will be attending now are contributing to this. This first discussion is actually focusing on the hottest R&D trends in Earth observation. And I'm really pleased to be welcoming three very esteemed scientists and application developers. So you see here on my right, Evangelos Gerasopoulos from the National Observatory of Athens. Hi, Evangelos. He's also the sector lead for urban in FIRE. So he has been following very closely some of the work done in the focus groups. We also have Laurent Tits from VITO. He's team coordinator for agricultural applications. And you don't see her here among us, but she will be very actively participating online. I see she's there. Regula Frauenfelder, she's a technical expert at the Norwegian Geotechnical Institute. So with this, I would like to start the discussion. We will do it in two waves. So I will raise some questions to our panelists and we will enter into a dialogue. And you will also see, and I'm actually inviting Veronica to enable that, the first question for this panel will be now going live. So anyone participating, again, both here or remotely, you can give your ideas. The question here would be if you can name your top 3 R&D trends in the sectors you are active in your sectors. So with that, I will take my place here. All right. This has a deeper sound. Good. So, Vageli, I will start with you. You have been heavily involved in FIRE. I just mentioned it. You were following the work of the focus groups. You are also a key contributor, even coordinator of some key R&D projects. So, looking back at what was discussed in the focus groups, some of it we already saw summarized by the relevant evangelists, but also in your general experience, what would you say are key R&D challenges for Earth observation in the urban context?
Okay. So hello, everybody. Thank you, Lefteris. Thank you for the invitation and for your question. So in the urban domain, we are already seeing products that have come out and are of great help, like, for example, the Urban Atlas, as a pan-European land cover and land use information around functional urban areas. We have the global human settlement layer coming from the JERC. We have the world settlement footprint. It provides information about population at a very high resolution, and it's improving. And we've seen some latest progress in this aspect in the Living Planet Symposium, incorporating like the height of the buildings, like the gender and age information about the population, which is very important for the urban domain. We have thematically, vertically, some very nice applications with regards to air quality, with regards to the urban heat island, green space, etc., etc. So one first attempt to gather all these urban applications, let's say, together has been the EO Toolkit for Sustainable Cities and Human Settlements from the EO for SDG initiative in Geo, focusing on SDG 11 in cities, but still it's one first attempt to gather all this information and bring it out to the real world and the end user. So taking this as a reference, I would say that the main challenge and the main trend for R&D could be culminated under one word. That would be integration. And I'm very happy that the word integration has been referred to from other speakers before, which means that at least we are converging and we are understanding where things should head at. And by integration, I would put many elements inside. First of all, in situ information. This has also been mentioned before. But when you go to the urban level, in situ information is really crucial, not just for providing the ground truth for satellite and remote sensing information, but also on its own to resolve complex issues that cannot be seen from space. Then another element that we most of the time is neglect including in Earth observation is modeling. So again, cities are a very nice domain where high resolution models can cover the gaps between in situ information and satellite information. And the last one, from the Earth observation point of view, let's say, would be the citizen science. I mean, we cannot do stuff about cities without taking into account the citizens themselves, how they become aware of the different elements that they can get from Earth observation, but also how they can contribute in this process. That would be the normal stuff, I would say. What I see now as also as a trend, which is happening in here and there, is the integration of socioeconomic information. And it is important to move from a point where we just provide layers of information to the point where we are able to understand the socioeconomic implications of what we are trying to achieve, combine them with the information we can provide, so that at the end of the day we end up with vulnerability and the real impact of our interventions. So how can we probably do that? This is a discussion that is already taking place in Geo, and the proposition behind is to work over nexus areas to understand the links between the different domains, because also this knowledge and actually this traction between the different domains might also create the new needs for Earth observation. There are many great examples of projects that are starting to be doing this. I'm happy to be part of one of these. It's a national project, a Green Deal project. So it's actually about a systemic approach to find the pathways for creating solutions for cities. This is the pilot Athens, for example, where I realized, and someone else mentioned that we are not going there to sell the EU projects. We are being part of a process to resolve a progress along the whole value, tools, cost, the pathway to achieve, and then the Earth observation solutions comes as one of the tools that could facilitate this process. And I see that the uptake from the end users through this process, it comes a little bit more natural. So we need to have more in these directions. And I would finish my intervention by saying that, for example, 10 years ago, at least in Greece, 10, 15 years ago, when we started having the first projects where the industry had to work together with the research centers, at the beginning, we were not there. So the first meetings was like awkward dates, how are you? You didn't know what to say, etc. So, but with time, it worked well. We established common language, and now we see at the European level how much this has progressed. So in the same way, R&D should focus in bringing together all these different areas and start with creating the common language and then building upon this.
Thank you. Thank you very much, Vangeli. You actually raised some very interesting topics, both on the thematic side, but also on the ways for the different stakeholders to collaborate. I would like to pass on to Laurent. We have seen in recent years that there are new observational capabilities, was actually mentioned quite a few times also here, looking further into the future. We also have seen new ways to process or visualize data. And many of these are actually focusing on land applications, including, of course, agriculture. So looking into all that, what would you say stands out as key trends in your sector?
Okay, thanks. Well, if I look at the past 2 years, I obtained my PhD about 10 years ago. And then the trend was really just like, okay, you do your research in a small area, you collect your own in situ data, you download all the Earth observation data that you need, and then you do your research for 4 years on your computer, and then you publish your results. If you see how research is being conducted nowadays, it's completely different in the sense that very little research is still done at the few parcel level. Look at the demonstrators done by ESA, the whole world series that they do, like world soil, world cover, world cereal. Like it's still at the parcel level, it's still 10-meter resolution, but the results need to be demonstratable at a larger scale. They need to be demonstrated at the global level. And that has a lot of implications on how research is done and how researchers approach their issues as well. If you see the way we handle in situ data is completely different, and it was already mentioned here. Before you collected your own in situ data and you did your research. Now, because of the scalability, your own in situ data is only a very small part of the whole research. So you need much more collaborations with other institutes. You need to get that network up and going to be able to do something meaningful as well. So in that sense, the whole data repositories that are popping up now as well is part of that trend, like you see it in Europe as well, with the common agricultural data space and so on. So they're trying to organize this whole in situ data availability that comes next to the Earth observation data capabilities as well. So I think that's a trend that you see. And so the sharing of data is just becoming more and more important, and being open with your data. But also, if you look at the whole cloud computing, is a big part of that as well. You cannot compute the world at 10 meters at your own laptop. So you need to go to the cloud. And so a lot of the research goes there as well. What are the implications on your research when you want to do it on the cloud as well? So it's not just finding just the right algorithm to find or to estimate yield, or to do crop classification at the local level. If you want to do it at a larger scale, you need to look at how to use in situ data. How can you make your algorithm transferable over different areas? So a lot of the research is switching also from doing something locally to how to make it scalable. And you see that in the AI trends as well. A lot of the AI trends go to scalability, how to work with only a limited amount of in situ data, or if you have in situ on one area but not on the other area, how can you still do something meaningful in these other areas? So you see that the transferability of results is coming in there as well, quite big. But what you see, then maybe the last point is, you have a lot of these global demonstrators coming now as a research, they're mainly research products or research projects. So global demonstrators, and actually it was quite striking at Living Planet for me. If you went to the presentations and you went to the posters and you saw what some of the big players are doing, and then you look at the universities, the research is completely different. You see quite a big discrepancy between the research being done, because before the research was mainly university task, but now due to like Copernicus program, like the calls from ESA, research is also more and more being done by large institutes and by the industry themselves as well, or by SMEs, and the universities are playing a different role there. And so if you look at research done by PhD students, they still work quite locally. And then you have these larger institutes and companies that do research also and development at a completely different scale. And so there's a bit of a mismatch there now as well. And I think one of the reasons, because we're still quite a lot of contact with universities as well, is making the step for students and researchers to go to the cloud is quite a big step. And you need a lot of already quite some experience with that technology in order to do research in that context. So they still struggle a bit at the local scale, while a lot of the other research is going on at a much larger scale. And they're looking at completely different research questions there as well. And then maybe my last point that I want to make is, if you look at the trends, so right now, like I mentioned, there's a lot of large-scale demonstrators, but that's also for universities, for example, an issue. There's so many products coming out as a demonstrator. So what's usable, what's reliable, what's the accuracy? For which applications can I use it? For which applications should I still process my own results? And so there's a lot of things being published, but it's not always clear what's usable and what's not usable. And so we need to be much more transparent and open and on what we actually produce and make available to the wider community. Because there's always side notes, there's also areas where it works really well, areas where it doesn't work well. So we need to be very open on that as well, just to make sure that the research community as a whole can benefit from it and move forward.
Thanks, Laurent. That's actually very interesting. And this notion of how much of the research that is done then transforms into something operational or usable anyway, I think it's a very important theme to keep here. I would like to move on with Regula. So here in infrastructure, we heard also the Evangelos present many things, but we also heard similar aspects from the energy and raw material side, where key topics like climate change, extreme weather events, lately, of course, there's a lot of discussion around supply chain autonomy. They are defining or redefining the sector. And obviously there is a constant need to efficiently monitor and promote sustainable solutions. So in light of all this, in light of the overall context of these things happening, which directions do you see R&D taking?
Yeah, thanks for the question, Lef, and thanks for the invitation to talk to you. So in my field, which is kind of, as you mentioned, is kind of infrastructure focused, I really see several topics that will be the new trends. And first, there's several of the other topics that have already been mentioned by the Laurent and Vasilis, but what hasn't been mentioned, I think, and which is really important in our field, is constellations. That we go away from that we have one satellite that takes an image over an area at one day, and then we have to wait for 12 days or in earlier days for a month until we get the next picture, and another ones to get another picture, to really do these satellite constellations where we make use of several satellites together that work in conjunction. We have, for example, the Maxar constellation that gives an intraday revisit over most rapidly changing areas that has already been proven to work for example, in disaster monitoring or in defense operations. We also have the new mission that's planned by ESA, Harmony, where two passive SAR satellites shall make use of the signals that the Sentinel-1 satellites send out, and they just kind of work in conjunction with this Sentinel-1 satellite. So I think this is really something that's going to get more and more important in our fields, because we are addressing rapidly changing environments and challenges. We can also mention Planet, where we now have like one image over each area for the entire globe each day, which really kind of gives the data volume that we haven't had before. Other points that already have been touched by my other panelists are the cloud computing, and I think that's really also a key, and that it's easily accessible. We have Google Earth Engine, and I see, for example, with the students that I have attend, that they're kind of really embracing this very fast, and it gives them unprecedented possibilities to take their local field study and try applying it with EO data in a bigger context. I have, for instance, one student in the first year, she kind of tried to map landslides after a landslide event in Norway, just kind of on a very local scale, and then she kind of got their eyes open for Google Earth Engine. And now last week, she kind of showed me examples from Japan, from South Africa, basically from case studies from all over the globe. And she did that once she had the script, she was able to do that in the course of a couple of minutes for each of the target sites. So I think here we have really a big yet not fully exploited potential. Another one that goes hand in hand with that, and I mentioned the scripting, you need to have smart algorithms, and there's a lot of talk about machine learning and deep learning approaches. I think they're definitely here to come and grow even more, but I think you also can use smart algorithms that not are per se machine learning algorithms, but that just kind of make smart use of a lot of different type of data. One type of data I would like to mention here is the forthcoming European ground motion service, where we get INSAR derived ground motion measurements over entire Europe within the course of a few years. And here we really, I mean, there's so much data hidden, or kind of messages and hidden within these INSAR measurements, that here it's really, we have the need for smart algorithms and machine learning and deep learning that kind of try to get out this information that's also behind the mean deformation measurements that we get. Has also been mentioned, we do need to combine more data, not even EO data, but in situ measurements from, in my field, for example, core drillings, geotechnical data. For this, we have to collaborate more. This has also been mentioned before, and we really have to kind of make use of all these different type of data. And we also can use again then the combination with the EO data to make more targeted in situ information. I don't think we will get totally away in my sector from in situ data, but with the help of EO data, you can make them much more targeted and really, for example, drill where it's needed, and not like 10 years ago, you just kind of had to drill an entire area because that was the only possibility to get any data. Another point that I think will become even more important, it's already on the rise, are digital twins. Tools that help us to streamline design processes and to eliminate many aspects of prototype testing by using 3D simulations and interfaces such as augmented and virtual reality. And by this, you can really test your prototypes before you go out into real life and production. All this is heavily relying on digitization and making use of digital tools. And I think with this also comes a challenge, and that's my last point. I think we also need to more and more explore tools and develop tools that limit our vulnerability that comes with this increased use of and dependence on digital services. I think that's an extremely important point, that we start to rely fully also in our everyday life on digital services. I just think about our mobile phones, and this makes us very dependent and also very vulnerable. So I think one of the next big topics also has to be how we kind of can diminish or decrease this vulnerability. Thank you.
Thanks a lot. You have covered actually a very nice list of very interesting topics. I've noted down many. I think one of the themes that all three of you have pointed out is this integration of Earth observations from remote sensing, but also from in situ data or other information that, of course, is specific to the different sectors. I also wanted to now perhaps look into a little bit what has been raised by the audience. Many of you have touched these parts, but we could do a very quick discussion. For instance, hyperspectral. This has gained quite some interest. I'm sure, Laurent, you are looking into that. If you can share a few thoughts about how you see this transforming your sector.
Okay, thanks. Yeah, hyperspectral, absolutely. We were already looking at it when I was doing my PhD, because NMOP would be launched soon at that time, but it was quite delayed. So now finally NMOP is there. We're all really excited about the satellite. So now it's a bit the research about what we can do given the spatial resolution of NMOP, because we're now a bit spoiled with what we get with Sentinel-1 and 2 at 10 meter, and now we have to go back a bit. But definitely we're looking into it. It's going to open a few additional areas that we cannot cover at the moment, especially related to like, how should I say, like quality related variables in agriculture, like your nutrient content. So how well is my crop growing, nutrient content, also diseases. And so in that respect, it goes more on what's in my field, so what we can do with Sentinel-1 and 2, to how well is it actually doing? What's the status of my crop? I think there's quite a bit of opportunities, and especially I think the soil component, which is quite difficult for the moment. So really get insights on the soil component. Hyperspectral is there absolutely something we are looking into.
Thank you very much. Just to, for the benefit of anyone who doesn't see these points, I would also like to raise the fact that there were comments around AI data visualization and microplastic detection. There was a comment about ecosystem services accounting. Of course, there was a mention around the near real-time image processing and delivery, federated platforms, hybrid AI, where I guess this comes back to what Regula mentioned, that it's not only, let's say, the deep learning, but you also need to have good, smart algorithms themselves. And I think with that, I will close the first wave. We're also a little bit short in time, and we would pass on to the next part. So we heard a little bit about the different types of R&D trends. This follows on with the previous discussion, but let's now discuss priorities. So I would open the first question to all three of you. Maybe we can start with Regula this time. So if you were asked to design an R&D strategy in your sector, what would be your absolute #1 priority?
For me, it would, and I mentioned this point before, the exploitation of the forthcoming European ground motion service. Because in my field, we use a lot of INSAR, also interferometry, deformation measurements in big infrastructure projects for big national clients in Norway. And with this new European ground motion service, I think that's an unprecedented possibility for all the European countries that will be covered by this ground motion service to really do data mining and kind of, I think it's going to be an eye opener for many fields, but especially in the infrastructure field. And for this, we need, as I mentioned, we need the smart algorithms, the machine and deep learning approaches. It doesn't really matter actually what you call them, but we need these smart algorithms to harvest the information, all the information that's within this ground motion service. So for me, that would be it's a bit a narrow kind of strategy, but it's really targeted to where I see where our clients in the daily life have their needs. They're really, I mean, they phone me up and ask me, well, what have you seen in your last processing? Are there any changes? How is the quarter to the left of my new excavation pit? How is it doing? Is it stable? Has it increased, or have we kind of have an increase in the velocity of the deformation? So yeah, that would be my absolute first priority.
Thanks. Bagele, would you like to pick this next?
Yeah, thank you. So we are talking about the urban domain. We've heard about, and we know, we live, the complexities of the urban domain. So cities have to comply with different frames. We are talking about resilient cities. We are talking about sustainable cities. We are talking about zero carbon cities, about smart cities. We have mentioned well-being as an overall asset for a city. So I would put all these aspects under a bigger umbrella. I would call it urban climate adaptation, which seems to fit the case. And what would we need for this? We would need a robust monitoring frame, some capacity development in order to address the above issues, and of course the establishment of appropriate indicators. So my absolute priority would be to showcase all those Earth observation tools that are already addressing these different aspects of climate adaptation. Make sure that we understand the problems, the progress, and improve and tailor our existing tools, or even develop new ones, taking into account the new progress that's coming with sensors, etc., etc. And then make sure that everybody, especially the urban planners, understand the benefits of the exploitation of the Earth observation use, and we create test beds to work more on the nexuses that I mentioned before. So at the end of the day, the output should be integrated decision support tools and assessment tools, where all the aspects, holistically, socioeconomic aspects, etc., would be incorporated and would be made available to decision makers. So that would be my hot priority, let's say.
Thanks. And maybe Laurent, if you can comment on that as well.
Okay, thanks. Maybe I can agree with what Regula said, in the sense that we have a lot of data already being generated with a lot of data products. We're really now a bit like the data mining step, if you want, where you go and see what's actually behind all of that data. For example, we've been collecting in Belgium a lot of data since 2017. We basically know not everything, but a lot of what's going on in the field. but just to see, so what are the insights we can gain from that? Like, for example, the effect of crop rotation on productivity, for example. We can do it for the whole of Belgium. We have all the data there, just a matter of doing the right statistics and the data mining techniques. So I think that's something that's still been done too little by a lot of people. So I think that's definitely a direction. But I think, so that's one, just to comment or compliment on her comment. But what I think for us in our roadmap, like the way forward is really, and I mentioned it before, is how to get the most out of having only a limited amount of reference or in situ data, and how to deal with that. How can you still do a good research? How can you still develop performant products with only a limited amount of reference data? And that goes quite wide. And you have the whole AI families coming up, like self-supervised learning, or you can really look at marriage between more the modeling community and the AI community, because they can already do a lot due to the modeling. And then if you can combine it with AI, it opens up a lot of opportunities, transferability of methods. So it's very wide, but the fact that if you can combine these different areas will result that you can do much more with only a limited amount of data. So that's for me a bit the key direction to go to the coming years.
Thanks a lot. And maybe entering now the final topic that I would like to raise, because we are discussing it a little bit, obviously drawing from our own experiences, but we haven't shared specific experience. So do you have any best practice or success stories that you would say we need to build on and see an R&D program of the future leverage what was done there? This is maybe Evangelos, you want to jump first?
Yeah. I mean, this is a big discussion. I think the key word here is operationalization. When things need to reach the level of operationalization, then things change. So I'll use an example from our own group. What was the problem in Greece a few years, 1 decade ago? It was, for example, due to the economic crisis, smog event, large quantities of smoke over the city. The regulatory networks were not able to capture the details behind and tell the true story behind. So we started working with sensors. So research and development gave us the opportunity to calibrate, to understand that under different, let's say, chemical composition conditions in the city, sensors do not behave the same. So at the end of we also understood that the density needed to cover this aspect, it's not covered, and it cannot be covered also only by satellite. So we built a network of sensors, and we moved to have it now operational and giving information to the citizens and the local and regional authorities in different events having to do with, for example, pollution episodes, wildfires, or industrial accidents in the area of a city. So all this progress that came naturally, if you see it now, from a third eye, I think it's a good example how from a problem you can do the research and then go to something that can work operational and really deliver something useful to the stakeholders.
Thanks. Laurent?
Okay, thanks. Well, if you talk about research and the transfer to operational services, what we try to do, and as an example of good practice, as you mentioned, is when doing the research and the development, already take that operational context into account while doing your research. For example, we had to develop methods for crop calendars, so like emergence, harvest, so what's happening on the field. And if you look in the literature, they always say you have to use coherence, because coherence has the highest accuracies. It's very sensitive. If you use coherence, you can do it very well. But coherence is usually not available on different data platforms, like the DIASs, they usually don't have coherence data. If you have to compute it yourself, it's very expensive. So while doing the developments of these methods, we always looked at, okay, what if we use coherence and what if we don't use coherence? Like, what's the impact on the accuracy? And do we really need it, yes or no? And yes, usually the accuracies were higher, but for example, if we don't use coherence, we went maybe from a, I think it was from a 5-day accuracy to a 4.5-day accuracy. I mean, that's still good enough. And then if we have to scale it to the European level, and now we have to provide it in the context of Copernicus, we have to provide it all over Europe on an annual basis. it has a very big impact on your cost and speed context. So in that way, we were able to make sure that we had a method that was scalable, that was deployable, and still with a very good accuracy. But it was, from a scientific point of view, maybe not the method with the very highest accuracy that's out there.
Thank you. And maybe to wrap things up, Regula, would you like to share some thoughts on this?
Yeah, I would also kind of like to share the story of a project that we had, because I think it really illustrates also something that Evangelos has mentioned, kind of how to involve the stakeholders and how important that is. So a couple of years ago, we were able to carry out the R&D project, then at that time funded by ESA, to exploit the potential of EO data for snow avalanche warning. And we have a lot of road and railroads that are exposed to snow avalanches in Norway. So we tried to get those stakeholders on board of this project, and also the avalanche forecasters. And they were in this project, but especially the avalanche forecasters were really skeptical, because, you know, resolution of data and how should this work, and bad weather when the satellite comes, stuff like that. But during this kind of having them on board and having them through this project on the journey all the way, and kind of being able to show them both the failures and the successes during the project work really was key for them to, after a while, embrace these products. So nowadays, I mean, I still remember the first time when I discovered the first snow avalanche in one of the backscatter images. That's a couple of years ago now, but today this snow avalanche detection service from SAR data is actually operational at the National Avalanche Warning Service at one of our directorates. And it's used by the forecasters on a daily basis during winter season. So the same people that were very, very skeptical to what we proposed from a non-avalanche part in the beginning really embraced this product in the end, because they were, as I mentioned, they were part of the journey. They see how it evolved, and they saw right from the start kind of the pros and the cons, let's put it like that. And it was also a way for them to understand how we did it, and also for us, it prevented us to kind of to oversell something to a potential client, because they really knew, in the end, they knew what they got.
Thanks a lot. I think this actually kind of creates a nice bridge with the next panel session, because here we have covered a little bit how R&D can be scaled into becoming operational. This still often has a local dimension in Norway, in Greece, in Belgium. The next question is how this can become scaled at a grander level. And there, of course, policy making has a big role to play. So with that, I would like to thank all three of you very much for your insights. So we can go for and we will go straight on to the next panel discussion.